For this problem, we're asked to construct a third-degree polynomial that has zeros -2 and 3i when the function's value at -3 equals 36. So, first of all, we begin by noting that a third-degree polynomial n equal 3 means there's 3 zeros. And they give us 2. So we know -2 and 3i are zeros, but if there's 3 of them, we also know that -3i, the conjugate of 3i, is also a zero, because imaginary zeros always come in pairs. So if we have these 3 zeros, then the factor theorem tells us that our polynomial can be rewritten as the product of the factors with a lead coefficient we'll call a sub n, and then x minus each of the zeros. So x minus -2 as a factor, x minus 3i as a factor, and x minus -3i as a factor. So the first thing we can do then is take each of those minus and negatives and turn them into a plus, a positive. So there's one there for the 2 and then another one for the -3i. And now we need to expand the 3 different factors. And the easiest place to start is actually with the back 2, because they are conjugates, and when you multiply conjugates with complex numbers, they turn out to be nice-looking polynomials. So we'll copy the a sub n in front, the x plus 2 factor, and now we'll start multiplying out the other 2 factors. So x times x will give us x squared. And if you're paying attention, you don't really have to do the outer and the inner pairs, because we know they're conjugates and we'll add to 0. But just to show that, we'll go ahead and do them anyway. So for the outside, we have x times positive 3i. That'll give us plus 3ix. And then for the inside, we have a -3i times x, and we get a -3ix. And then for the last, we have a -3i times a positive 3i, so that'll give us a -9i squared. Okay, so as you can see, we have a positive 3ix and a -3ix, so they add to 0 and drop out. And now we have to do a little bit more work with that I squared attached to the -9. So we're down to x squared, these 2 are gone, and then minus 9 times I squared. And remember that I squared can be replaced with a -1. So what we have here is a -9 times a -1. And that will make for a plus 9. So when we multiply it, x minus 3i times x plus 3i, we end up with x squared plus 9. So now what we're going to do is multiply the remaining 2 binomials. So we'll again copy the a sub n, and now we'll multiply this out using FOIL. So the product of the first, x times x squared, will give us an x to the 3rd power, or x cubed. Then for the, I'm actually going to do the inside next so that my terms are in descending order. So the 2 and the x squared will get us plus 2x squared. Then I'll come back and do the outside. So the x times the 9 gets me 9x, and you can see how the terms are now descending order. And then our last 2 times 9 gets us 18. Okay, so we've kind of completed the first step in this process of rewriting the polynomial as a product of factors and then multiplying out those factors so we have an expanded polynomial. So the second part now is to find let me move this up. Actually, we're going to need to use that piece of information. Whoops, wrong thing. Back here, there we go. The f of -3 is 36. So we're going to do a polynomial function at -3, and I'm just using p for polynomial, it was given as an f, is equal to a sub n. And what we're going to do is replace each x with the value of -3. And because it's negative, we have to be very careful with this. So we have a -3 cubed plus 2 times -3 squared plus 9 times -3 plus 18. Okay, now we know that the function's value at -3 is 36. That was the given piece of information. And what we're trying to do here is find our value of a sub n. So we have to do some calculations here. So -3 to the third power, 3 negatives would make a negative, and 3 times 3 is 9, times another 3, 27. So -27. Plus 2 times -3 squared, and -3 squared, -3 times -3 is 9, positive 9, times the 2 gives us an 18, and then a positive 9 times -3 is -27, another one of those, and plus 18. Lots of the same numbers showing up. So, working these numbers a little bit further, we've got 36 equals a sub n. I would put together the positives, so 18 and 18 is 36, and then the negatives, -27 and -27 is -54, so the net result is -18. Okay, so one more step. I'm going to then divide both sides by -18, and I'll know my value of a sub n. So we end up with, I'm going to turn this around, a sub n equals 36 divided by -18, so a -2. Okay, now what we do is we put this all together. So our polynomial function equals, but now instead of a sub n, we're going to put our -2, and then all the information we have already found. So our x to the third plus 2x squared, and so on. And then the final step to complete the problem is to distribute that -2 to each of these terms, and then we will have our expanded polynomial. So -2 x to the third, bringing that in, we'll now take the -2 times the +2 for a -4 x to the second, and then -2 times the 9x, and then finally the -2 times the 18. And that gives us our final answer. That is, the polynomial we constructed is third degree. We can see n equals 3 right there. And it has zeros of -2, 3i, and as we also added, -3i. And if we were to put -3 into this problem everywhere there's an x, we should get out a 36.